here we are in the second half of our earth science class, and we've moved from geology and we're moving into the various other branches of earth science. So today we're going to discuss hydrology. Most of our fresh water is currently trapped in the great glaciers, and to quote one of the most famous rappers, ice, ice, baby. So what is a glacier? It's a massive ice that is partially on land or all on land, but the key is it's moving or has moved in the past or present. They are very important in erosion because these moving glaciers act like huge plows. Glaciers exist on all of the continents, even Africa, in the alpine glaciers. Australia doesn't have glaciers, but Oceania does because New Guinea and New Zealand both have smaller representative glaciers. Valley or alpine glaciers are the most common, but the largest are the continental ice sheets, and right now there's currently two of those, one in Greenland and one in Antarctica. So the alpines have three parts. The cirque, which is the smallest alpine glacier, sits in the bowl. A piedmont is where it spills out onto the floor, and the valley glacier is the carved V-shaped steep walled valley that is being carved by the glacier. This illustrates the three stages of alpine glaciation. The continental ice sheets or continental glaciers are pictured here. Like we said, glaciers have to be moving. They flow down valleys and they shape the landscape. We call the growth or unfortunate loss of glaciers the glacial budget. The zone of wastage is where glaciers are retreating. The zone of accumulation is where they grow. Glaciers are key in erosion. The most common is abrasion, but plucking also is a form of glacial erosion. When the ice melts, plucking leaves boulders, which we call erratics. Here is evidence of glacier erosion, one in New Zealand and one in Alaska. So these steep walled valleys are glacial valleys. And generally at the head of a glacier valley is the cirque, or where the glacier originated. There is an image of a cirque right there, highlighted with the bowl-shaped origination of the glacier. Artets and horns are peaks that are left behind by glaciers. Moraine is deposition. Lateral would be on the sides, medial would be in the middle, and terminal would be at the end of the glacier. The fjord is the glacier valley that is now full of water. It's generally connected to the sea. Fjords are one of the major types of estuaries in the glaciated northern hemisphere. Landforms are caused by glacial drift, the sediment transported and deposited. Some of the terminology, till, stratified drift, would be deposited, and erratics would be formed by plucking. And we mentioned before, the moraine is the collective term for glacial depositional landforms. This illustration shows you the different type of moraines. The outwashed plain is caused by the melt water, and it is a flat area that has been scoured by water. Kettle lakes are chunks of ice that have melted, leaving deep, round lakes. Drumlins are elongated hills formed by glacial movement. Eskers and kames are ridges and hills caused by glacial deposition. As you can see by this illustration, an ice age is a period of Earth's history where you have ice sheets, and we are still in an ice age, but we're in an interglacial portion of the ice age because most of the glaciers have retreated. At the peak of the last ice age, the Wisconsin glaciation, this is how far the glaciers retreated, or how far the glaciers were. They since retreated, but you can see that most of North America and most of Europe and parts of South America, Australia, and even Africa had huge glaciers. Sea level was 400 meters lower. As those glaciers melted, sea level rose. Some of the major formations: Long Island is the terminal moraine of the glaciers. The Great Lakes were left behind by glacial melt. The Mississippi was lengthened from a small river in Illinois to what it is today, all the way to the Gulf. Sea level, like I said, rose over 400 meters in a very short span, and those tales of Noah's Ark seem to originate from the formation of the Black Sea, which flooded out much of that civilization. Glaciers are caused to the change in temperature of the Earth, some natural, and of course we do have human-influenced climate change, which is causing our glaciers to recede at a greater rate than expected. Reductions in solar radiation, volcanism, shifting of continents, which would change ocean circulation, uplift would also cause climate change. Those are some of the natural factors. Now, the changes in Earth's orbit, obliquity is our axial tilt, and that's changing, which changes our climate. Eccentricity is how egg-shaped or circular the orbit is, and that has changed. And precession is Earth's wobble, and that also changes our orbit around the sun. So these are all natural. Humans have nothing to do with these factors that go into climate. Of course, humans do with the carbon dioxide emissions and changing of the atmosphere composition and temperature, and we have had some alarming glacial retreats over the past century. Moving from glaciers to, well, this is actually a landscape caused by glaciers. This is Niagara Falls, but running water, very major agent of erosion. So hydrology, we started with ice, now we're moving to the running water, stream flow. And we'll start with the water cycle or hydrologic cycle. Most of us are familiar with it, but look at the evaporation and evapotranspiration. Evapotranspiration is caused by the plants moving through the vegetation, and it's estimated 10% of the water cycle comes from plants, 10% comes from fresh water, and 80% is evaporation from the oceans. Condensation in the upper atmosphere leads to precipitation, and then the water can either run off or, more commonly, infiltrate and become part of our groundwater. River systems is the runoff, stream flow, streams and rivers, moving water. The drainage basin or watershed refers to the area that collects water. The largest in North America is the Mississippi River drainage basin. You can see the western portion is called the Continental Divide. All the water that forms to the west of that blue line flows to the Pacific. All of the water that flows to the right of the blue line either flows into the Gulf or the Atlantic, but then the Gulf joins the Atlantic, so eventually it all hits the Atlantic. So rivers have various structures. The dendritic pattern is the most common. The tributaries are the small streams or smaller rivers that drain into the main river. And we measure stream discharge. It's very important because water management here, it's very, very important for flooding because we have to do that. We have to manage the drainage basins. And stream discharge is one of the things measured. It's velocity times the area. This is a profile of a stream. If you look at A to A prime, you can see that on the curve 1, that would be where erosion occurs. Curve 5, that's where deposition occurs. Because as water rounds the corner, much like if you make a turn in a car, you get pulled to one direction. B to B prime is a straight area of the channel where erosion and deposition are equal. And C to C prime, 1 would be the area of deposition and 5 would be the area of erosion. So straight channels have a uniform bottom. You can see a U shape or like a tub. B to B prime, you can see that's called a meander. And where you have the curve, it's deeper. Where you have the, where B prime is, that's the area of deposition, it's shallow. So your stream channel shifts over time because of the meanders, the curves. Streams also mature. Youthful streams have V-shaped, swift-moving valleys, few tributaries, swift, steep changes of elevation. Over time, the valleys erode and a floodplain develops, meanders, wetlands form, and the soil gets deeper, richer from deposition, and eventually the stream slows down. So an older stream has a lot of curves, a lot of wetlands, a wide U-shaped valley, big floodplains. Young streams, swift-moving, V-shaped, steep valleys. At the end of your stream, you generally have a depositional landform, in this case a delta, where it runs into the Gulf or the ocean. Levees are another depositional landform. They're caused by flooding and then sediments left behind. A natural levee is the river bank or stream bank. We mimic that when we build channelized streams. Alluvial fans are much like a delta, except they form at the end of a valley, not into a big body of water. Floods generally cause more property damage and more death than any other natural disaster. And that's why discharge, stream flow, and all of this is so important. On average, more than 100 people a year die from flood. That can be greater when we are hit by 4 or 5 hurricanes in a season, but on average, and 18 inches of water is all it takes to move a vehicle, your typical vehicle, you know, a lowrider. 100-year floods are what insurance companies use to estimate your flood insurance or insurance values. Now, things that we can do To control floods, obviously levees, artificial, natural, retention ponds, channelization, and then other solutions aimed at controlling your river. Most of our water here in Florida and billions of people worldwide depend on groundwater. Aeration means that there's air and soil and water mixed. Saturation means there's no more air, it's just water and soil. And the water table is the zone where above it we have aeration, below it we have saturation. Now, like I said, many people depend on groundwater for drinking. 98% of our water that's usable is stored in aquifers, groundwater. We don't consider those ice caps and those glaciers that we spoke of usable. Aquifers and aquitards are what confines our groundwater. By the way, potable water is what we call usable by humans. So there is an unconfined aquifer and a confined aquifer. Confined aquifer has impervious bedrock all around it, and unconfined can flow uninhibited. A spring is where the water table is above and then the water flows out of the ground. Generally it's in limestone because the limestone is dissolved, especially here in Florida. Hot springs are where we have hot water flowing out because there's some sort of tectonic activity. Geysers are your eruption of water due to tectonic and volcanic activities. Of course, a well is how we utilize this groundwater. You have to drill below the water table to pull water out. The water table fluctuates, so a well has to be below the water table's lowest part of the year, or else the well will run dry. An artesian well is, you can see, a free-flowing well, and that is below the water table. That needs the confined aquifer, and then the water pressure causes it to flow. Springs are artesian in nature because they're below the water table, so the water flows out naturally.